Cool. So we were on number 2. The Apple Pen is a Bluetooth device. This is correct, Owen, and I had to reconnect it. It got disconnected. Now it is reconnected. I have a pen. I have an iPad. I have a computer. We have power. We have all the things. We are ready. Okay, so you had to write a piecewise defined function. I'm going to make my function f of x, and it is going to be defined in 4 parts. Part number 1 is the acceleration part, from 0 less than or equal to x less than or equal to 10. And part number 2 is for the next 50 seconds. So that's going to go from 10 less than but not equal to x less than or equal to 60. Then I've got 10 seconds of deceleration. So that's 60 less than x less than or equal to 70. And lastly, 20 seconds of hanging out at the bus stop. 70 less than x less than or equal to 90. And the first part is, well, it's going to be something squared. So I think you guys know from physics, those of you who have had physics, know that it is a times t squared for some constant a. So we know we've got time squared, or in this case, x squared. And we want, wow, the image is pretty fuzzy, huh? Oh, well, I guess you're living with it. We know that the input 10, when I plug 10 in, I should get out 50 seconds. So 10 squared is 100. 100 isn't 50 seconds. That's not what I want. So when I plug in 10, in order to get 50, I'm going to take half of x squared. When I plug in 10, 10 squared is 100. Half of that is 50. Cool. So I have a constant acceleration piece. Now I want to go on to constant velocity. So that's a linear function, y equals mx plus b. And I know the slope is 10 because the speed is 10. And I again know that when I plug in 10, I should get out 50 because I had the same point, 10, 50, that I know is on the function. So when I plug in 10, 10 times 10 is again 100. Really? Set it at least 360p. Should we try that? I'll try it. Okay. So I made some settings. Oh, yours looks fine, Kevin? Okay, cool. Sweet. Gotcha. If it looks fine, then it looks fine. Sweet. Sounds good. Let's see. Where was I? I was here. Oh, I plugged in 10. 10 times 10 is 100. And I want to get out 50. So I don't like this, that I only have that I have 100 and I want to get 50. I want to get this value to come down to 50. So I'm going to say minus 50. Now here, I can't change this into like half of it. I can't make this 5x. What I need to do is keep this as a 10 because I know the slope is 10. So that's required. So I'm fine as long as I keep the slope at 10. So that's why I'm using minus 50 rather than taking half the slope. 10x minus 50, there we go. Now I've got this deceleration section. So we already figured out that if I want to accelerate and travel 50 meters in the course of 10 seconds, that I've got this relationship, 1/2 x squared. So I'm going to keep that, but I know I'm decelerating, so I'm going to change it to negative 1/2. And then now I'm trying to find out, okay, at what point am I finally stopped? I'm finally stopped after 10 seconds, 50, so that's a total of 60, and then another 10, so that's 70 seconds, right? This is the point, 70 seconds, where I'm finally stopped. So I need to move this deceleration parabola over 70 seconds. I'm going to say minus 70. That's a horizontal translation by 70. Then I need to say, okay, how much have I traveled? How far have I gone by the time I get to stopped? Well, I went 50 meters in the first 10 seconds. Then I went another 500 meters at a constant velocity. So that's 550 total. Then I went another 50 meters while I was slowing down. So that's 600 total. So I got to say plus 600 here. And then lastly, now I'm stopped. I'm 600 meters away from where I first began. So 600. B, sketch a graph of your function. Any questions on A? I'm going to wait for a second and let you guys catch up. Don't worry, Brendan. You didn't miss much. I took like an hour to get started. We've only been really doing math for like 10 minutes total. Oh, by the way, I had to buy a new app. Oh, Oscar, I think I'm just going to do the 6 problems. These are similar to the ones on the test. Anyway, I had to buy a new app to make this work. So you guys owe me. Those people who bet me $1 in 4th period, I need those dollars. This is extreme, I see. Interesting. Well, I don't hear any questions on A, so let's do B. Sketch a graph of the function. And let's pull in some graph paper. Cool. Here we go. We've got x-axis, there's my y-axis, There's my x-axis. I know time needs to go out to 90, so I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90. And I know distance has to go up to 600. So I'm going to say 100, 200, 300, 400, 500, 600. Sorry. I'm kidding, you guys. I don't need any money. I'm glad that I got it to work, though. Anyway, 10 gives me 50, so I'm going to plot that point. 10, 50. And I know that's a parabola in that section. Then I've got between 10 seconds and 60 seconds. I go the next 550 meters. So that takes me to here, and that's linear. Then I've got another 50 meters in another 10 seconds, and that's a parabola, an upside down parabola right there. So this is parabolic here and there. And then I'm constant for the next 20 seconds, so flat line to 90. There it is. There's f of x. You guys want to see it in Desmos? So it was f of x, and it equals on the first section was 0 less than or equal to x less than or equal to 10, and we had 1/2 x squared. Then the next section is 10 less than x less than or equal to 60, and we have 10x minus 50. Let's zoom out so we can see this. So there it is. Here's the parabola. You can see it's curved along this section. And then you can see by the time we get to 50, oh, sorry, after the first 10 seconds, this is curved. But then after those 10 seconds, we've got linear section. And now I've got up to 60 graphed, so that ends there. But now I come back to here and I say next section, which goes from 60 less than x less than or equal to 70. And I want negative 1/2 x minus 70 squared plus 600. And you can see now I've got the last section, don't I? Oh, that's the problem. 70. There it is, squared. That's better. Cool. And it is parabolic upside down on this section. And finish it off. We get the very last section, comma, from 70 less than x less than or equal to 90 colon, we want 600. There it is. There's your whole function. Questions on anything from number 2? Hey, the speed is actually pretty good here. It's not that much lag. I'm impressed. No, we're okay. Number 2, we got this stuff? No questions? Okay. Number 3. Let's see. We plug in all these parts. Cool. So I'm going to go ahead and do all of the parts A first. So A, on I get f of x. Let's write it out so we're clear. G of x equals f of x plus 4, which equals x plus 4 squared. And this is a perfectly good answer. If you stop there, that's fine. But if you also wanted to say x squared plus 8x plus 16, that's also fine. Either. Okay, so now step 2, we're at h of x equals g of x minus 3 equals x plus 4 squared minus 3 equals x squared plus 8x plus 13. Sweet. Step 3 was j of x equal to h of negative x equals negative x plus 4 squared minus 3 equals negative x squared plus, really, minus 8x plus 13. And when I square negative x, I really get x squared. Cool. And step 4, we've got k of x equal to j of x over 3, which means I replace each of the x's with x over 3. So that equals negative x over 3 plus 4 squared minus 3, if I'm using that form, or 3 squared minus, let's see, let's make this 8x over 3 plus 13. I don't know. Was that confusing, the fact that I did that? Would you prefer I said, I don't want to not show my steps very well? Really what I should have done, so how about I back up? Oops. What I should have done here was said minus 8, and remember I'm plugging in x over 3. Just to show we're doing it the exact same way. And then when I do negative 8 times x over 3, yeah, that's what I'm trying to say here, Owen. If you did this one, this is all good, or this one, this is all good. Either are good. But anyway, this last one after we expand it would be x over 3 squared minus 8x over 3 plus 13. I was just skipping a step. So, and then even if we want to take a last step, we could say that's x squared over 9 minus 8x over 3 plus 13. Cool. So that was part A. I'm going to put part A away. And Owen, did I answer your question? Is that good? Hopefully. Anyway, part B. Let's see. On I, we had x plus 4. That's a horizontal translation. Right. Oh, no, sorry. Left 4 spaces. Left 4. Or we could say translation by vector -4, 0. Good. 2. Down 3. Vertical translation. Down 3. Or I could say translation by 0, -3. Cool. Step 3, we've got a reflection over the y-axis. And step 4, dilation about the y-axis by a factor of 3. All of the points become 3 times as far from the y-axis as they used to be. Cool. I'm going to put part B away, which brings me to part C, sketch a graph of all of these parts. Okay, there's part A, there's part B. Pull in some graph paper. How are we doing? Are you guys having questions? Are you confused? I'm not getting much input from the crowd. Brennan, it's good? You understand everything? You're set? Glad to hear it. Okay, let's see. I'm gonna graph. Let's see. Here's my y-axis, and here's my x-axis, and we've got our first function is f of x, and it equals x squared. So looks something like that. And like that. And thanks, Brennan. I appreciate it. Let's see. Our first thing moves at left 4. So this is, let's write it down. This is f of x. And then we're going to go right 4, left 4, left 4. 1, 2, 3, 4. So now there's our new piece. Let's see, I'm just going to copy this one and move it left 4 since I have a computer. Oh, there'd be 1 spot, 2 spots, 3 spots, 4 spots. Sweet. And that one is g of x. And then I can duplicate. And now I can move it. So here it was. The next part moves down 3. So down 1, down 2, down 3. And, ooh, I should have made a new color. Just kidding. So I'm going to copy this one. With a nice green. And grab it. And pull it down. 1, 2, 3, 4 spaces. Oh, thank you. Down 3. Appreciate it, Oscar. 3 minus 3. Better. Perfect. And that is. And then it gets reflected about the y-axis. So I'm going to do this one in yellow. Kind of an ugly, pukely yellow. That'll be nice. And I'm going to again copy them because it has reflective symmetry. I can just move it over, and we're going to see where it lands. And grab it. And so here it goes. 1, 2, 3, 4 spaces would take it to the x-axis. We want to move it to the other side of the x-axis. Okay, so another 1, 2, 3, 4 spaces. There it is. It's flipped over the x-axis. Ooh, I can't just copy and paste on this one. So that was j of x. And now every single spot and move it 3 times. Oh, I flipped over the y-axis. Thank you. Oscar, excellent question. If it was a y-axis reflection, I'm talking about f of negative x, which is what I had here, was inside. If it was an x-axis reflection, it would have been negative f of x. That's not what you meant, Oscar? No, I'm. Tell me what your question is, Oscar. I'm not sure. I agree with that. You alone know what you don't know. Can you tell me what your question is or no? Oh, I see. Gotcha. Cool. All right, we're on it. Great. I need to dilate by a factor of 3. So every single point needs to get 3 times further from the y-axis than it used to be. So this point, vertex, which used to be at 4, negative 3, is now going to be at 12, negative 3. So I'm going to go out 4, 5, 6, 7, 8, 9, 10, 11, 12. There it is, 3 times as far away. So here is the old distance. Right? Here's the old distance. It got multiplied times 3. So once, twice, 3 times as far away. 3 times as far. And that happens to every other point. So the graph used to go over 1, up 1. Now it's going to go over 3, up 1. And over 3, up 1. It used to go over 2, up 4. Now it's going to go over 6, up 1, 2, 3. Over 6, up 1, 2, 3, 4. It used to go over 3, up 9. Now it's going to go over 9, up 9. 2, 3, 4, 5, 6, 7, 8, 9. Cool. So there's our new dilated function. K of x. Solid. Questions on what's that? Number 3? 3. Nope. Cool. Awesome. Number 4. We had that graph from the book. Let me grab it. Cool. And let's see. We want to write a piecewise defined function that would model this graph. So we're going to say part A, I'm going to call it f of x. And it's got 1, 2, 3, 4 parts. And the first part is, let's see, I see the graph going up 1, 2, 3 spaces and over 1. So up 3 over 1 means slope equals 3. So I can write 3x. You can see it's linear. Hopefully you all see that too. And let's see, where would the y-intercept be? Well, if I went over another one, I'd be up at 4. And another one, I'd be up at 7. So 3x plus 7 if, one more space. Let's see, we're between negative 3 less than or equal to x less than or equal to, no, negative 2, not bad. Negative 2, that's better. Next section is just 1. So 1, if we're between negative 2 less than x less than or equal to 0. And up 1 over 2. So this section, I go up 1 over 2, slope equals 1/2. 1/2 x if in 0 and 2. And last section goes down 2 over 1. So slope equals negative 2. So we're here and we've got negative 2x. Extend my brackets a little bit. That's better. Negative 2x, and let's see. If I went back one, I'd be at 4, 6. Plus 6. We're between 2 and 3. There we are. There's my function for part A. For part B, let's see. In general, I like distance time graphs. I think they're pretty easy to understand. Let's see. The hair is terrible. Ooh, I'm going to type. I'll be faster at typing. Oh, lost some. Plus 6 if 2 less than x less than or equal to 3. And here we go. Let's see. The hare is really bad at running races. In his race with the tortoise this time around, he decided to start 3 hours before the race began, and he began 2 miles before the starting line. He walked for, let's see, up 3/1 for 3 miles in 1 hour, going 1 mile into the race. But it was still 2 hours before the race started. Why does the third one not have a y-intercept? Oh, thanks, Michelle. A half x plus 1, right? What was I doing? There it is. Y-intercept, right there, 0, 1. Good catch. To the y-intercept, that's why. Anyway, my story. It was still 2 hours before the race started. Stopped and waited for the race to begin. He then waited, let's see, 2 hours. He then began at a crawl because he was feeling bad about his head start of 1 mile. And he covered 1 mile in 2 hours. That is slow. Then he felt so bad, he walked the 2 miles back to the beginning of the race in 1 hour. Yeah, so your story doesn't have to be particularly good, and it doesn't have to make all that much sense. The graph. And I'm going to say, after that, he was so depressed, he decided not to race after all. Cool. Questions on any of the details of my story or my piecewise defined function? No? We're okay? Cool. That was number 4. Let's check out number 5. Oh, why does the first equation have plus 7? Great question. The first equation has plus 7 because its y-intercept is 7. So if I were to see, get rid of that and that and that. So if I were to take this line and continue it, so here it is, it goes up 3 every time it goes over 1. So if I were to go over 1 again, it would go up another 3, and I would be up here at 4. And if I were to go over 1 again, I would go up to 7. Here would be the y-intercept, as Michelle said. That would be at 7. Is that okay, Owen? Hopefully. Gotcha. Cool. Okay, credit cards. This is a very generous credit card company. They are not charging these people very much, but that's the problem your book had. So let's do it. So first of all, we've got a graph with a nice a set of constant functions. Kind of fun. Doing that. There we go. So let's see. I'm going to make the instructions a little smaller, my graph nice and big. I don't need part B right now. So this is A, and my graph is nice and positive. All right, A was find the function and graph it. Okay, so A, we've got f of x equal to, and it says for less than 10. So the entire amount is due. So f of x equals $10 if x is less than 10. For a bill of but less than 500, the minimum due is $10. Oh no, so this wasn't 10 back here. The entire amount would be x. So if f of x equals x, if 0 is less than x less than equal to Oh no, not less than, less than. Cool. And then f of x equals 10. If we're equal to 10, all the way up to 500. And minimum due is 30. If we're between 500 but less than 1,000, then 50 is due. If we're between 1,000 but less than 1,500. And finally, we get up to 70. X is greater than or equal to 1,500. And again, I need to extend my brackets. There we go. Okay. So now we want to graph that. So let's see. This needs to go out to 1,500. So I'm going to say 100, 200, 300, 400, 500, 7, 8, 9, 1,000, 11, 12, 13, 14, 1,500. Is that right? No, I did not. That was 500, 6, 7, 9, 1,000, 11, 12, 13, 14, 1,500. Cool. And my y-axis needs to get up to 70. So 10 bucks, 20 bucks, 30 bucks, 40, 60, and 70. And let's see. For less than 10, I'm going to zoom in here. Way in. Way in. We're so zoomed in. Here is 50. 25. Here's 10. This is x equals 10 in here. It's linear. We get x. And it's got a hole at the top. No, does not have a hole at the top. Because we're continuing to 10 for values all the way out to, and now I can zoom out. We've got 10 all the way out to 500. Section that I had to zoom way in to get, and then it stays 10 for bills that are all the way out to 500. But at that point, it does have a hole because we're discontinuous at that point. So the next set is 30 bucks if we're between 500 and 1,000. So this is where our value continues out to 1,000, and again a hole at 1,000. 50 bucks between 1,000 and 1,500. So here we are at 50, where our graph continues for 1,500, and again a hole. And then 70 is the next section, and that goes on to infinity. Yeah. So again, itty bitty linear section, which is hard to make to scale and still see it. But that's very important. Cool. That was part A. We got a function f of x and we got a graph. Sweet. To part B, unless there are questions there. Okay. Doesn't seem like it. Part B. Yeah, we're good. Cool. Thank you, Christine. So part B, the card holder may pay any amount between the minimum due and the total owed. Issuing the card charges the card holder interest of 1.5% per month for the first $1,000 owed and 1% per month on any unpaid balance over $1,000. Find the function g that gives the amount of interest charged per month on a balance of x dollars. G. So again, I'm going to want to graph. Let me pull that up. Okay. And g of x this time. So g of x is going to equal, and I only need a two-part bracket this time, but 1,000 owed, we've got a balance of x dollars. So 0.01x for, oh no, 1.5%, 0.015x. We've got x less than or equal to 1,000. And over 1,000, we just got point. So now we need to think and say, all right, if you had to pay 1.5% on your 1,000, you'd be at $1,500, right? And now you're gonna owe 0.01x plus the $1,500 that you owed for the first 1,000. So 0.01x, if we plug in like 1,000, would give us 100, but you already owe $150, so we got to say plus 50 to get this to be continuous. If we're between, if it's x is greater than 1,000, that's all we need to put. If x is greater than 1,000, there we go. So here's my y-axis. And my x. And we got 1,000. So we go 1, 2, 3, 4, 5, and say there's 500. 6, 7, 8, 9. There's 1,000. There's 1,500. And then we're going to need to get up to 150. So 100. So here's my function. It starts at 0. $0, $0. To 1,000. No, up to 150 if you owe $1,000. And at that point, it changes slope and continues to go up, only up 1/1. Cool. There it is. Questions on number 5. Can I go over why it's plus 50 again? Sure, I'd be happy to, Sophia. If you don't mind, I'm going to look at Desmos. It's really similar to the same thinking as we did here, where we said, how are we going to make the bus be continuous, right? The bus can't be like the night bus in Harry Potter. It can't just like hop around. We have to make a continuous function. So if I started with f of x equal to, let's see, we were on the interval. The first interval was x less than or equal to 1,000, and we were at 0.015 x. So basically, if you're here, you have $1,000, $150. Now, Sophia, if I just said continue this function and say next domain is for x greater than 1,000, and then if I said greater than 1,000, you only owe 1%, right? So 0.01x. Now, see why this would be a really odd graph to have? If I just make it 0.01x, say, okay, 1% if you're over 1,000, it's not as if as soon as you get over 1,000, you get to pay $50 less. No, it's if you're over 1,000, you don't pay as much interest, but you still have to pay the 150 that you owed to output, right? Oh, sorry, 15. Wow, they really have low interest here. 15. You don't get to pay $10 less, $5 less. It didn't drop you. So we need to do the plus, really only plus 5. Plus 5 to make the graphs continuous. Does it make sense why this would be a more reasonable function to have, Sophia? Where we've got the next bit, it's 1% on top of this part. So I'm just translating the graph up so it becomes continuous. Beautiful, beautiful. Good answer. Hey, number 6. I did a lot of work on number 6. There you go, make a new number 6. Okay, here we go. Number 6. Sketch a graph for the function f of x equals negative 1/2 x plus 4 squared plus 6 if x is less than 0, 2/3 x minus 2 if x is between 0 and 9, and negative 2x plus 20 if x is greater than or equal to 9. So let's start by sketching graph. Again, I want graph paper. Okay. There's my x-axis. And here's my y-axis. And let's see, first section, -1/2 x plus 4 squared plus 6. So I'm going to say here's -2, -4, and 2, 4, 6. So I know, because I know about how functions get that this is the x squared function that has been moved to the left 4 and up 6. So I'm going to put here's my function, -4 up 6. But other than that, oh, it's also going down, and it has been dilated by a factor of 1/2. So I'm going to say it used to go down 1, now it goes over 1, over 2. There we go. And let's see, 4 squared would be 16, but we're at 8. Cool. So there's the first section, and it goes over to here. Alrighty. Then I've got 2/3 x minus 2 if 0 and 9. So 0 times 2/3 is 0. 0 minus 2 is -2. And the fact that I have, if I plug in -2 here, it would give me, sorry. The fact that if I plug in 0, it would yield -2 here. And also here, if I plug in 0, I would also get -2. Means that I don't want to draw an open circle here, because I know that the point actually gets filled in when I get to this function. If these two were discontinuous, I would use an open circle at this point, if the rest of the function started off over here. But because the function continues here, I don't want an open circle. So up 2 over 3. There we go. Up 2 over 3. There we go. And all the way out to 9. 7, 8, 10, 12. So here's 9. Up 2 over 3. But at this point, I am going to want an open circle, because the function is not going to be continuous at that point. So open circle does come right here, because when I evaluate -2x plus 20, when I plug in 9, -2 times 9 is -18, plus 20 is 2. So the graph continues right there, and that's where I get a closed circle. And it goes down 2 over 1. So the graph is off this way. Cool. And there's f of x. The domain range. A. Domain goes off to the right. So domain x such that x equals all the real numbers. Or from negative infinity to infinity. And range looks like it gets up to 6, but that's as high as it goes. So we can say f of x such that f of x is less than or equal to 6. In other words, negative infinity to 6. Cool. B, intercepts. Well, I gave you another problem that had tricky intercepts to find. We got a couple options for finding them. We could solve this function for 0. That would be an option. Or you could go on Desmos and evaluate it, since you're not actually on the test. On the test, I'm going to give you one with nice, easy intercepts, but this one is hard. I happen to know they're at 7.5 and negative 1.5, so I'm just going to write them in right now. But in this case, we could just get that by estimating, right? And in this case, this happens to be a pretty good estimate. So I'm going to say this point is negative 7.50, and this one is negative 0.50. So those were the intercepts. B. We've got an intercept at negative 7.50. We've got another one at negative 0.50. We've got one at 0, negative 2, and that's a y-intercept. Then an intercept at 3, 0, and the last x-intercept is at 10, 0. Okay. C, increasing and decreasing. C, where are we increasing and where are we decreasing? So we're increasing, looks like from negative infinity to negative 4, and also from 0 to 9. And we're decreasing on the spots that we're not increasing. So that's from negative 4 to 0 and 9 to infinity. Cool. Last up. Oh no. Next up is Extrema. Part D, Extrema. We have a max point at negative 4, 6. Right there. Max. And we have a min point. Minimum value at 0, negative 2. Minimum. And that's it. Lauren, excellent question. Something well worth noting. I need to say I'm increasing from negative infinity to negative 4, not to 6, because I say where I'm increasing based on the x-axis. The y values tell me whether or not I'm increasing. The x values tell me where I'm increasing. This is where I stop increasing, and that is at x equals -4. Oh yeah. Glad you asked it though. Again, I'm counting this at -4 because here's -4. That's where I stop increasing. And then again over here, I'm saying this is at 9 because that's where I stop increasing at x equals 9. Wait, where'd my max and min go? Did I lose them? I lost them. I did a max and min. Oh, well, they're gone now. Okay, so I had an extrema. There's a D, extrema, and I said max, -4, 6, minimum at 0, -2. -4, 6, right there. 0, -2, right there. And this point, what about E? Yeah, I haven't done E yet. I know, I just lost my part D, Rebecca. That's why I did it again. So this point is, by the way, it seems like it ought to be a maximum point because this is high and that's high. But we've got two issues here. One is that here we're increasing all the way up to that point, but not including it. So that can't be a maximum point because we never actually reached that point. And then here, this can't be a maximum point because the value of the function right next to it is higher than it. Because as soon as I go to the left, I get higher. But over here, I never actually get to a high point. So we actually end up with no maximum point over here. If this part was higher than that part, we could have a max point because this part is filled in. Or if this part was filled in and this one was open, we could have a max point up there. But as it is, we have no maximum point in this section. But part E, thank you, Rebecca, making sure I caught it. Part E, discontinuous at x equals 9. Cool. That's it. That's all there was. Questions for me? You are welcome, Lisbeth. I'm glad we got it to work again. I was going to be sad. You're welcome, Sophia. You're welcome, Michelle. Doesn't sound like there's any questions. I guess I will see. Oh, no. We don't do partner tests. Tests are always individual. Sometimes we do partner quizzes, but not tests. You are welcome, Jasmine. Good to know, Brennan. You are welcome, Ryan. Yeah, I think you should not fail tomorrow, Lisbeth. That's an excellent plan. Don't do that. Cool. Well, if there are no questions, which it seems as if there are not, I will see you all tomorrow for a test. Have a good night.